purpose here is to learn how to construct a perpendicular bisector. And so I'm going to try to go at this from a more cognitive perspective, since procedure is not always the best way to learn something. So remember, when you're trying to construct a perpendicular bisector, the idea is that for it to be perpendicular, if you were to imagine a pole standing up like a telephone pole, and if you had some guy wires, I guess they're called, you want them to hold that up exactly straight. And to do that, you want to make sure that every point on the pole is an equal distance from the end points to make it stand up straight. If that was not an equal distance from each, if you had a point that was a different distance from one side to the other, you would have a leaning pole, or you would have a pole that is not bisecting the line segment of the ground. Okay, so see, this is one length and this is a longer length. Okay, so the point of using your compass is to make those distances the same. So when you have a line segment, what you want to do is find a couple of points that you can draw your line through that are equal distance from the endpoints. So what you're doing with your compass, you got to open it up at least halfway. What you're doing is saying, okay, here's a bunch of points that are an equal distance from the one endpoint. They're all exactly this distance right here, from tip to tip of your compass. And then from the other endpoint, you're going to make another set of points that are exactly this distance from the end point. Now we have this point right in the middle, right here, that is exactly the same distance from both endpoints. Okay, and then what you want to do with your compass is to also find a point that's an equal distance from both endpoints down at the bottom. Now you can connect the two points to make a perpendicular bisector. Now if you were to check this with your compass, this point here is an equal distance from both endpoints. And this point here is an equal distance from both endpoints. Okay, you can make your compass even a little smaller, and you can say this point right here, where those two cross, is an equal distance from each endpoint. Okay, and that's how the compass is a measuring tool, because what it's doing is it's holding a distance. Like if you were to try to measure the height of a friend, and you would find a point on your body that was a certain distance, or if you tried to measure, like if you wanted to copy the length of this, how you would hold your hands apart, or you would find something about that same distance apart. You're doing the same thing with the compass. Okay, so let's do a couple of perpendicular bisectors so you can get the procedure down. Okay, there's a line segment. To get the perpendicular bisector, put your sharp end of your compass on one end. Let's see, let's do both of the arcs first. And draw an arc. Now you can kind of imagine in your mind, when I go to do this, okay, let me start again from the beginning. I already have in mind about where I think it's going to be. Now I'm not actually drawing this in there, but with my mind I'm thinking, okay, it's got to come through here somewhere. I can imagine it. And so when I go to draw my arcs, I'm going to put my arcs about where I know that line is going to be. And then I'm going to fine-tune exactly where that line is by drawing both arcs on both sides from the end point of each end point of my line segment. And then I connect those 2 points. and I know that this is perpendicular and that it bisects this line segment.